Unit 5 Current and Resistance. Lesson number 5.6 Resistors in Parallel. Learning objectives. In the end of this lesson, you'll be able to derive an expression for the equivalent resistance of more than one resistors in parallel. Calculate the current across resistors in parallel. Calculate potential drop across a resistor in a circuit. Solve problems related to the topic. Keywords: equivalent resistance, parallel connection, and current divider. Two resistors can be connected in parallel, which divides the current between them as shown in the adjacent figure. Again, to better illustrate the potential drops, Figure B shows the same circuit in a three-dimensional view. Parallel circuit rule for voltage. Because all components are connected across the same voltage source, the voltage across each is the same. For example, the source voltage is 5 volt. What will a voltmeter read if it is placed across each of the resistors? As you see, the voltmeter will read the same amount of voltage across each of the resistors. In parallel connection for resistors, the potential drop across each resistor is equal to the potential difference provided by the source of EMF. Using Ohm's law for current I1 in R1 and current I2 in R2, we have delta V EMF equal delta V1 equal delta V2. I1 equal delta V EMF divided by R1 and I2 equal delta V EMF divided by R2. The total current for the source of EMF I must be I equal I1 plus I2. Inserting the expressions for I1 and I2, we obtain delta V EMF divided by Req equal delta V EMF divided by R1 plus delta V EMF divided by R2. Then 1 over Req equal 1 over R1 plus 1 over R2. Exercise 1. What is the total resistance? If the two resistors R1 equal 27 kilo ohms and R2 equal 56 kilo ohms connected in parallel, 1 over Req equal 1 over R1 plus 1 over R2. Then Req equal 1 over R1 plus 1 over R2, all power minus 1. Then Req equal 1 over 27 plus 1 over 56, power minus 1, equal 18 kilo ohms. In general, the equivalent resistance for n resistors connected in parallel is given by 1 over Req equal summation from 1 to n, 1 over Ri, resistors in parallel. In the case of symmetric resistors in parallel, Req equal R divided by N, where N is the number of resistors and R the resistance of every resistor. Now let's talk about current divider. When current enters a junction, it divides with the current values that are inversely proportional to the resistance values. The most widely formula for the current divider is the two resistors equation. For resistors R1 and R2, I1 equal R2 divided by R1 plus R2 times total current, and I2 equal R1 divided by R1 plus R2 times total current. Note the subscripts. The resistor in the numerator is not the same as the one for which current is found. Exercise 2. Tabulating current, resistance, and voltage is a useful way to summarize parameters in a parallel circuit. Continuing with the previous example, complete the parameters listed in the table. As you see before, the potential drop across each resistors in parallel is equal and equal to the potential difference provided by the source EMF equal 5 volts. And by using Ohm's law, I1 equal 7.4 milliampere and I2 equal 3.3 milliampere. I3 equal 2.3 milliampere and the total current equal 13 milliamperes. Example 3. Three identical resistors R1, R2 and R3 are wired together as shown in the figure. An electric current is flowing from point A to point B. Choose the right answer about the current flowing through R2. A is the same as the current through R1 and R3. B is a third of the current through R1 and R3. C is twice the sum of the current through R1 and R3. Or D, 3 times the current through R1 and R3. Correct answer is A is the same as the current through R1 and R3. Of course, because the three resistors identical. Exercise 4. Which combination of resistors has the highest equivalent resistance? Combination A, combination B, combination C, combination D, or the equivalent resistance is the same for all four? Correct answer is the equivalent resistance is the same for all four. Exercise 5. Adjacent figure shows a circuit with 6 resistors R1 through R6. What is the current flowing through resistors R2 and R3? Strategy: to find the equivalent resistance, first find the equivalent resistance of the series connection of R3 and R4. Then use this result to find the equivalent resistance of the parallel connection with R1. Then use this result to find the equivalent resistance of series connection with R2, R5 and R6 to get the equivalent resistance. The current through R134 is the same in R2, R5 and R6 equals the current from the battery can be found using Ohm's law and the voltage applied. The potential drop V134 across the resistors R134 is the same as the voltage across R1 and R34. Can be found using Ohm's law. V134 equal V34 equal I times R134. The current through R3 can be found using Ohm's law. V134 equal I3 times R34. R3 and R4 are in series, thus we can write R34 equal R3 plus R4 equal 6 plus 10 equal 16 ohms. Then R34 and R1 are in parallel. We can then write R134 equal 1 over R34 plus 1 over R1 all power minus 1 equal 1 by 16 plus 1 by 12 power minus 1 equal 6.9 ohms. R2, R5, R6 and R134 are in series, thus we can write R equivalent equal R134 plus R2 plus R5 plus R6 equal 6.9 plus 8 plus 12 plus 6 equal 32.9 ohms. Thus, I2, the current flowing through R2 is given by I2 equal delta VEMF divided by REQ equal 64 divided by 32.9 equal 1.95 amperes. Now we turn to determination the current flowing through R3. Current I2 is also flowing through the equivalent resistor R134 that contains R3. Look at figure C. Thus we can write V134 equal I2 times R134, where I2 equal the total current of the battery. V134 equal V34, then I2 times R134 equal I3 times R34. So I3 equal I2 times R134 divided by R34 equal 1.95 times 6.9 divided by 16 equal 0.94 amperes. Exercise 6. In the figure, R1 equal 1.90 ohms, R2 equal 0.980 ohms, and R3 equal 1.70 ohms. What is the equivalent resistance of this combination of resistors? A. 0.984 ohms, B. 1.11 ohms, C. 1.26 ohms, D. 1.42 ohms, or E. 1.6 ohms. Correct answer is 1.1 ohms. Exercise 7. As more identical resistors are added to the circuit shown in the figure, the resistance between points A and B will A. increase, B. stay the same, C. decrease, or D. change in an unpredicted manner. Correct answer is C. decrease. Exercise 8. The circuit shown in figure A has 4 resistors and battery with VAMF equal 149 volt. The values of 4 resistors are R1 equal 17 ohms, R2 equal 51 ohms, R3 equal 114 ohms, and R4 equal 55 ohms. What is the magnitude of the potential drop across R2? R2 and R3 are parallel connection, so R23 equal 1 by R2 plus 1 by R3 power minus 1 equal 1 over 51 plus 1 over 114 power minus 1 equal 35.2 ohms. So R equivalent equal 17 plus 35.2 plus 55 equal 107.2 ohms. And the total current equal VEMF divided by REQ equal 149 divided by 107.2 equal 1.39 ampere. V2 equal V23 equal IT times R23 because R2 and R3 are in parallel connection. V2 equal 1.39 times 35.2 equal 49 volts. Exercise 9. 3 light bulbs are connected in series with a battery that delivered a constant potential difference VEMF. When a wire is connected across light bulb 2, as shown in the figure, what will happen to light bulbs 1 and 3? A. Burn just as brightly as they did before the wire was connected. B. Burn more brightly than they did before the wire was connected. C. Burn less brightly than they did before the wire was connected. Or D. Go out. The right answer is B. Burn more brightly than they did before the wire was connected. Let's summarize. In parallel connection for resistors, the potential drop across each resistor is equal to the potential difference provided by the source of EMF. VEMF equal V1 equal V2. The total current for the source of EMF I must be I equal I1 plus I2. In general, the equivalent resistance for n resistors connected in parallel is given by 1 over Req equal summation from 1 to n 1 over Ri, resistors in parallel. Thank you all and have a nice time.